So we're reviewing for your second exam over Zoom and the final exam. And so here's an example of a integral, definite integral from 0 to 1 of the integrand, which is e to the x times the square root underneath that radical. The radicand is e to the x and then plus 4. And then we have dx. So we don't know how to take the antiderivative of a square root that has more than one term or just not x under there. And so we're going to choose u to be something that we don't know how to integrate usually, or that will make it easier for us to integrate. So if I choose u to be e to the x plus 4, when we take the derivative of u, we get 1 du. Usually we don't put that one there, equals the derivative of e to the x. Derivative of e is just itself, e to the x times its exponent. But the exponent is just x, so it's 1. Plus the derivative of 4, which is 0. And then we tack on the dx. So dx, we need to know what that is in terms of u. And so we can get that by dividing what's in front of our dx. And so dx then is equal to du over e to the x. And so notice when we go back in and we substitute, I'm going to leave off the bounds for now, what we had chosen u to be, and replace what dx is with du, which is du over e to the x. Notice here that the terms with the x in it cancel out, and we need that to happen, so that that integrand is just in terms of what we chose that variable of substitution. In our case, we usually do u. The thing is that we have these bounds on here. And so those bounds were representative of x. And if we don't want to have to go back and do the substitution after we take the antiderivative, we can take care of that now by going in here and plugging in numbers. So I can let, well, the numbers are our bounds. So I'm going to let x equals 0. If we do that, we could figure out what u is. U is going to be e to the 0 plus 4. Well, a number raised to the 0 other than 0 is 1. So e to the 0 is 1 plus 4. And so this gives us u is 5. So u is 5 when x was 0. So we're going to do the same thing with our upper bound. When x equals 1, we're going to figure out what u is. So we have u is equal to e to the first power plus 4. This is just a number. It's just a 2.718 dot, 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 plus 4. So I'm just going to leave it in exact form. Okay, so we're basically in that where we can take the antiderivative. I'm just going to rewrite this square root of u a little bit differently to help you if you don't see it. This is the same thing as, right, u to the 1/2 power. So now we can just use that general power rule. We would add 1 to our exponent. So 1/2 plus 1 gives us 3/2. We divide by that new exponent, which is the same thing as multiplying by the reciprocal, because it's a fraction. So we're going to multiply by the reciprocal 3/2, which is 2/3. And we're evaluating this from u equals 5 to u equals e plus 4. So once we take the antiderivative and we're looking at definite integrals, we plug in our upper bound first, wherever we see, in this case, a u in that antiderivative. So we have 2/3 u, which is, in this case, e plus 4 for the upper bound, to the 3/2 minus, and now we're going to go in and we're going to plug in 5 wherever we see a u. So minus 2/3 times 5. And that 5 is raised to the 3/2 power. So there's really not much that we can do to clean this up too much. If they wanted it in an exact form, we can technically, if we wanted to, pull out that 2/3, but that's really not going to clean it up too much. And if we wanted to, we could rewrite our rational exponents and back in terms of radicals. So that 2 in the denominator, that's telling me I'm taking that square root of e plus 4. I can cube it underneath, or I can cube it outside, either way. I pulled out the 2/3 from the second term, so I have minus, same thing, rewriting the 3/2 power as a radical. So that's the same thing as the square root of 5 cubed. If you have a calculator, then you could throw that in and get an estimate. So if you throw that into the calculator properly, you should get 4.155. So let's just go over this. Let's say that you didn't realize or you forgot to change your bounds, or you just wanted to wait until after you took the antiderivative. So same problem. We had x equals 0, x equals 1. Let's just rewrite it. We already did the work with a substitution. And so with a substitution, we got u to the 1/2 du. Everything else canceled, but again, we're going to keep it here where we have our x values. So now when we take the antiderivative of this, again, we're going to add 1 to our exponent. So that's going to give us 3/2. Divide by our new exponent, which is 2/3, or is the same thing as multiplying by 2/3. And then this is actually, again, when x is 0 and x equals 1. But our antiderivative has u in it. So what we want to go back and do is we want to go back in and substitute in what we had chosen u to be here. And so now we can rewrite this as 2/3. U is this e to the x plus 4, all raised to the 3/2 power. And so now when we go and do our substitution back into the antiderivative, we're going to put in values of x. So the upper bound is 1. So we have 2/3 e raised to the 1st power plus 4, all raised to the 3/2 minus, now plugging in the lower bound. So 2/3 e to the 0 plus 4, all to the 3/2. And so notice that's basically, it is the same thing we had before. We can factor out that 2/3 if we wanted to. If we factor that out, and if this is just going to be e to the 4th to the 3/4, oops, not 3/4. I don't know why I put a 4 there. 3/2 power. I know why, because I was going to add a 4. Square root, this is e plus 4 cubed. We pulled out the negative 2/3. E to the 0 power is 1. So here we really have 1 plus 4. So that's just 5. So minus 5, that's a square root cubed. So either way, substituting in the bounds right away, changing the bounds right away, or wait till after you take the antiderivative, go back and substitute in what you had chosen u to be, and then keep those values of the definite integral, the bounds of our definite integral, the same in this case. So some of you might find it's easier to do it one way versus the other. They're both going to give you the same result at the end.